All right, lesson 4. What are we going to be looking at today? So we are going to be working with how to find the derivatives, how to find the derivative of an inverse. But I want to first kind of take a couple of minutes and remind ourselves a little bit about inverses. So the question I have posed here or to determine if f of x, which equals 1/2 x plus 5, and g of x, which equals 2x minus 10, are inverses. Well, when working with inverses, to determine if the two functions are inverses, this is kind of a two-step process. So this would be where if you take your f function and evaluate it at your g function, everywhere in your f function that you have x, you're going to replace that x with whatever g is. And so what that is here, if I put what is g of x, that's 2x minus 10. And therefore, we will, if I distribute, which I will erase that, when I distribute 1/2 onto 2x, I'm left with x, and when I multiply 1/2 to 10, I get my minus 5, and when I add 5, I ultimately end up with x. Okay, so, but this was a two-part process. Now the second part was to take the g function and substitute the f function. So you would evaluate g at f of x. So in the g function, which I have 2 times that stuff minus 10, so 2x minus 10, everywhere I have an x, I'm going to replace it with whatever f is. So I have 1/2 x plus 5. So when I go about cleaning this up and I distribute the 2, my 2 times 1/2 leaves me with x. 2 times 5 is 10. When I subtract 10, I'm left with x. So determine if the two functions are inverses. Yes, they are. What does that mean? That means that f of g of x equals g of f of x, which equals x. So the two composite functions both reduce down to x, and so that is what indicates that those two functions are inverses. So here's kind of the definition of the derivative for an inverse, and I've used 2 different notations because up here we talked about f and its inverse being f and g, but this could have been written not g of x, but because it's the inverse, I could write it as f inverse of x. So we're going to look at the definition in 2 different forms. All right, so let's let f be a function that is differentiable on an interval. If f has an inverse function, which we'll call f inverse, then f is differentiable at any x for which the composite function f of f inverse of x does not equal 0. Okay, that's just a lot of words. Okay, we have a lot of words over here too, but all I have done is changed out f inverse for g. So here's what you really have to know and take away from this. When you want to find the derivative of an inverse, then you can find it by 1 divided by f prime of f inverse of x. So if it's in the if you have your functions written in 2 different variables or 2 different notations like f and g, it would just simply be g prime of x, where g is the inverse, so the derivative of the inverse g is going to equal 1 over f prime of the inverse. Okay? So what I want to do now is I actually want us to derive the formula. So I want to take one of these expressions. We'll just take the composite function f of f inverse of x. Now remember, when you evaluate a function at its inverse, you know that the result will be x. All right, so in order for us to find the derivative of this, then I need to find the derivative using implicit differentiation of both sides, okay? So this derivative of f evaluated at an inverse, we have to use the chain rule. This is our little peanut. So the derivative of this will be f prime of the peanut, f inverse of x, times the derivative of the peanut, f inverse of x. Whew. And that is going to equal, what's the derivative of x? That would be 1. Okay, so now if we want to get f inverse prime by itself, then we're going to get this term by itself, and we do that by dividing f inverse prime of x equals, you have your 1 over f prime of the inverse. Okay, so there's the formula. All right, so let's put this into practice. Okay, now one of the things that you might try to get, sometimes you might be asked to find the derivative of an inverse, and when you do, I do not recommend trying to find the equation of the inverse, because it's most of the time it's really, really difficult. Okay, so here we have a function, x plus 2 to the second power. What is f prime? I want to keep this in the original form. I'm not going to square the binomial. I can use the chain rule pretty easily. So f prime of x equals 2 times the peanut, x plus 2, to the first power, times the derivative of the peanut, which is 1. So the derivative cleans up to be 2 times x plus 2. Okay, so now what if we want to find f inverse prime of 36? Well, first let's find f inverse prime of x. Okay, so here's what we've got so far. So f prime will be 1 over f prime of f inverse of x. So now I'm going to go in and replace my x's with 36. So f inverse prime of 36 will equal 1 over f prime of f inverse of 36. And what the heck? F inverse of 36. How do I find that? I don't have the equation for the inverse. Well, that's okay. I don't need the equation for the inverse. I can use the original function. If you remember that the x value of an inverse would be the y value of the original. So all I have to do here is go to my original, replace y, or f of x that is, with 36, set it equal to x plus 2 squared, and find the y value, or excuse me, find the x value. Don't multiply this out. Undo the square by taking the square root of both sides, and we get 6 equals x plus 2 equals 6, and we have x equals 4. okay? So I'm not finished because that 4 is just this piece right here. So let's see where this is taking me. All right. So what I have now, and I'm going to come down here, is F inverse prime of 36 equals 1 over F prime of 4. I found F inverse of 36 to be 4. So now I have 1 over F prime of 4, which I have F prime right here. So F prime of 4 is going to be 2 times 4 plus 2, which is going to be, what, 12? So F inverse prime of 36 equals 1 over 12. Okay? So 1/12 is the value of F inverse prime of 36. So 1/12 is the derivative of the function f, the derivative, 1/12 is the derivative of the inverse function evaluated at 36. So finding the derivative, especially at a particular number, involves some, you're going to need f prime. You know you're going to have f prime, and you know you're going to have to evaluate the inverse at a particular value. But in evaluating the inverse at 36 is the same thing as setting the function equal to 36. Okay? All right, so now let's go back. Let's do a different function and find f prime of x to the third. Well, f prime of x is going to be 3x squared. I want us to find the derivative of the inverse evaluated at 8. Okay, I do not know what the inverse function is, and I don't care. I don't need it. So here's what I know I'm going to need. I know I'm going to need, because of the formula, I know that I'm going to need f prime of something, but I'm also going to need f inverse of 8. And f inverse of 8 means take the function, set the function, replace 8 for the y value of the function, and in this case, x will equal to 2. So my function is f of x equals x cubed. I replace 8 for the y value and determine the x value. So now f inverse, so f inverse of 8 is actually going to be 2. I knew I had to find that part as well. But now I need to find f prime of 2. Okay, so f prime of 2 then is going to be 3 times 2 squared, and that is going to be 12. All right, I'm not doing my derivative, f inverse prime of 8 is found by taking 1 and dividing it by f prime of f inverse of 8. So what is f inverse of 8? I found that to be 2. So 1 over f prime of 2, and f prime of 2 is 12, and so we get 1/12. Okay, let me point out that these two functions, the inverses turned out to be the same, but that is a mere coincidence. That does not always happen. All right, so let's look at a couple more and see what we have. It says, let g be the function defined by g of x equals x cubed plus x. If f of x is equal to the inverse of g of x and f of 2 equals 1, what is the value of f prime of 2? Okay, so f prime of 2, what do we need? In order for us to find f prime of 2, I have to know what f prime of x is. Okay, so to find f prime of x, I'm going to take my f function, which is f of x equals g inverse of x, or the inverse of g of x. And so to find f prime, I will have the derivative of both sides. So d over dx, d over dx. The derivative of f of x is f prime of x equals. How do you find the derivative of an inverse function? Remember, that will be 1 over f prime of g inverse of x. And so now I can find f prime of 2. So f prime of 2 will equal 1 over f prime of the inverse evaluated at 2. Whew. Okay, how do we go about finding the inverse of g evaluated at 2? Well, we know g of x equals x cubed plus x. The 2 for the inverse is x. For the original g function, it will be y. So I take my 2, set it equal to x cubed plus x. And here's what I'm going to do. This equation is not going to be easily solved algebraically, but by inspection, let's think about a number that would make this equation true. So by inspection, meaning I'm just looking at it, wouldn't x have to be 1? So x has to be 1. If you take 1 and cube it, you get 1, plus another 1, you get your 2. So x is 1. And so now I can go f prime of 2 equals 1 over f prime of 1 and then I need to evaluate. That's not right, because this is supposed to be g. This is supposed to be g prime of 1, and this should be g prime of the inverse evaluated at 2. Okay, so now this is probably looking a little better. Sorry about that. So g prime of x is equal to 3x squared, coming from this, 3x squared plus 1. I will now substitute 1 in for x into the g function. I get 3 plus 1, which is 4. So f prime of 2 will equal 1 over 4. Okay, so my derivative will be 1 over 4. Okay, so kind of walking back through this, one of the things, okay, so this g prime of g inverse of 2, I fixed it here, but I didn't fix it over here, and this should be g prime of g inverse of x. Okay. We also, when we needed to find G inverse of 2, inverse G at 2, we substituted 2 for the f function, and set that equal to x cubed plus 1. But really, we need to think about this. We need to maybe not look at it from this perspective, but what do we know about inverse g of x? We know that the inverse g of x is equal to f of x because that's given, okay? So g, the inverse of g at 2 will be the same thing as f of 2, and we know f of 2 equals 1. So we were given that. We were given that right there. So that might make a little bit more sense to you than trying to look at that from just an inspection perspective. So what do we ultimately need to do now? To find f prime of 2, we wanted to evaluate or find 1 over g prime of g inverse of 2. So we now have g inverse g at 2 is being 1. So now we need to find g prime of 1. So we found the derivative of g. We substituted 1, and that gave us 4. So f prime of 2 is equal to 1/4. All right, and then let's look at one more, and let's take f of x equals the square root of x plus x squared plus 1, and I want us to find the derivative of the inverse of f at 3. Okay, so focusing on this, the derivative of the inverse at x, or I'll even go ahead and do 3, will equal 1 over f prime of f inverse at 3. That's our definition. All right, so let's find f inverse of 3. And that would be, all I have to do is substitute 3 for my equation. So that's 3 equals the square root of x plus x squared plus 1. In order to have 3, I'm adding 3 terms. If all 3 of these terms are 1, 1 plus 1 plus 1, that gives me 3. So would x equal 1? And the answer is yes. So when the inverse of x is 3, when f inverse of 3, that gives us x equals 1. Okay, so we have f inverse of 3, which is 1. And so now we need to substitute 1 over f prime of 1. And so f prime of 1, my derivative of f will be 1/2 x to the negative 1 plus 1 squared plus 1. Oh, I didn't, hang on. I jumped the gun there a little bit, sorry. So that's the derivative of the first term plus the derivative of the second term plus the derivative of the third, which is 0. Now I will substitute 1/2 times 1 to the negative 1/2 plus 2 times 1. Well, 1 to the negative 1/2 is just 1, so I'm looking at 1/2 plus 2, which is going to be 5 over 2. So now I have 1 over f prime of 1 is 5/2. When I keep, switch, flip, or whatever y'all say, multiply by the reciprocal, and I ultimately end up with 2/5. So the derivative of f inverse at 3 equals 2/5. In most cases, you have to find the inverse of the function evaluated at a number, and most of the time the inverse is going to be hard to find So you have to remember that the inverse, the x value of an inverse, is the y value of its function. All right, so what did we learn in this lesson? We learned how to find the derivative of inverse functions. And that'll be all for today.